Welcome all of you to the second application of Biot Savart'S law. First application I have discussed in earlier session. Second application is to find out magnetic field at point P on the axis of we have a circular conductor here. Its radius is say A. The radius of the circular conductor is A, and we are considering a small elemental length dl in the upper side. The topic is very interesting. You just see, this is a circular coil. This is the center O, and it has radius A, and this is the axis passing through the center of the coil, and current I is passing through the coil, right? And dl is the small elemental length as we have indicated here. So we are to find out magnetic field at point P on the axis of the circular conductor. Okay, so let us connect this point. So as you know, the magnetic field produced at point P, this point, suppose at point P, is perpendicular to both this distance. Suppose this is the R, this distance is R vector actually. The distance from this elemental length to the point P is R, and the magnetic field produced at P is perpendicular to this length. Okay, it must be perpendicular. Say this is 90 degree, and dB is the magnetic field direction. Okay, so it should be perpendicular to both R and dl. Okay, but it is easy to draw perpendicular direction with R. Okay, now you see, dB is inclined with the normal direction. What is the normal direction? This is the normal direction. This is the normal direction. Okay, and so dB vector has one component along this direction. dB vector has one component along this direction, in the normal direction. Okay, suppose that component is dBx component. Okay, dBx component. The other component is along the x direction, dBy. This is y direction, suppose. The other component is along dBx. dBx. This is dBx. Okay, and the angle here, this is the angle. Suppose this angle is recognized as phi. Okay, so this angle will also be phi. From the geometry, it is easy to recognize that this angle will be phi. Now, the dx, dBx and dBy, there are two components of dB vector. So, the magnitude of dBx component is given according to Biot Savart'S law as dbx, integration of dbx. Okay, so only component, suppose I am writing only component dbx. So if you write here the magnitude mu naught by 4 pi I dl sine of 90 degree r square. This is in accordance with the Biot-Savart's law. Why I am writing sine 90 degree? Another question. কোনোবা লেটকে সোমাইছে? Okay, you see dbx is the value of dbx, but here since it is a component, right, component of db vector, so its value is dbx cos of phi. Is it? You see, db vector has two components, one component along x direction, another component along y direction. So x component is this, y component is dby cos of phi. The phi is associated with this component, that is why it is cos component. X component will be sine component. This will be sine component, sine phi. And the phi which is associated with y component, it should be cos component. The other component will be sine component.
Sir, video to bhalke dekha nai.
So what I told you, that x component of db vector, that is db is a vector, it is not only a magnitude, it gives both direction and magnitude also. Therefore it must have two components, two rectangular components. One, the x component is recognized by sine phi, dbx sine phi. The other component is dby cos phi, right? Why it is sine, why it is cos? I already told you that suppose one vector is there, r vector, it makes an angle theta, then r vector, so this component will be r cos theta and this component will be r sin theta, right? When you resolve into two components, then we get cos component and sin component. The component which is connected with the theta, that is called cos component. Here the component which is connected with phi, it is the cos component. Y component is the cos component, x component is the sin component. Alternate to this. Okay. Next, you come. That is why we are to change this component dbx sin phi sin phi. Okay, this is sin phi. So question arises, why we are taking only the cos component, why not y component? Question may arise, but we are selecting only the sin component here, dbx, that is the x component, because you see the y component which is dby sin phi will be cancelled with another component which is exactly opposite to that. If we consider this current element at this point, we'll get same two components. That is why the vertical components will be cancel each other. All vertical components will be cancelled. There will be only remaining components along x direction. That is why no need to count this component. We will count only x component. That is why we are considering the x component to find the final expression, right? This is the main problem. Many students do not know why we are taking the sine component only, that is x component. So now why it is 90 degree, another question. Why sine 90 degree? So now sine 90 degree is taken because here the angle theta is 90 degree because it is the angle between the direction of dl. This is the direction of dl vector and this is the direction of r vector. There is 90 degree. If you consider this coil to be perpendicular to the board, then this direction will be perpendicular to r. So this will be 90 degree. So this gives the dl vector. Okay. That is, the angle between dl vector and r vector is 90 degree. That is why we are writing 90, sine 90. So you will get mu naught 4 pi I dl sine 90 is equal to 1, right? So sine phi is equal to what? In this right angle triangle, sine phi is equal to what? Perpendicular by hypotenuse. A is the radius. This is perpendicular. Hypotenuse is r. So A by r. Right? Now mu naught by 4 pi. Okay. Mu naught by 4 pi. And I dl r vector r cube a. Okay. This expression we found from the above calculations. Now again you can write r cube, since you see from the Pythagoras theorem r square is equal x square plus a square, right? From this right angle triangle we can find this expression. So r is equal to what? X square plus a square 1 by 2. Okay. Now if you give r cube, what you will get? X square plus a square 3 by 2. Okay. So in place of r cube you can write, x square plus a square 3 by 2. Okay. Now another points come. So you have to find out the net magnetic effect at this point. Okay. So net field, to find B is equal integration, you have to integrate this side. You have to integrate left hand side, right hand side. So for integration, mu naught by 4 pi, you have to exclude the constant terms IA. So x square plus a square 3 by 2. You have to integrate dl. Okay. So the value of integration dl integration is what? IA x square a square 3 by 2 into twice pi a. Finally, so twice pi will be cancelled. Mu naught by 2 I a square x square plus a square 3 by 2. So this is the expression. If n number of terms, if there are n terms, then you have to multiply this, then b will be equal to I a square capital N x square a square 3 by 2. Okay. Another condition is that if x is